I gave you to do was a resistor of 8 ohms in series with a 50 millihenry inductor. So and asked you to find the total impedance, the current, and the voltages across the two components. You know, the total impedance is given by the impedance of the resistor plus the impedance of the inductor. Simple series, but the inductor's got a J associated with it, making it a complex number. We need to find XL, so that's 2 pi FL, came out of 10 pi ohms. We can then put the resistance and the inductive reactance straight into the total formula in rectangular complex form and do a conversion with the calculator to get 32.4 ohms with a positive angle of 75.7. We know from the impedance phasor that if XL is upwards and R is to the right, we're going to end up with a total impedance that's got a positive angle because of that. So we know we're right. Yep. Then we use that impedance to find the current using a law, 1.54 amps at minus 75.7. Again, a check, got a lack of current. Does that fit right with the word civil? Yeah, an inductive circuit current comes after voltage. Right. Then we use that current to calculate VR. So we again Ohm's law with the complex current multiplied by the resistance, knowing that a resistor's got an angle of 0 ohms. We end up with 12.3 volts, angle minus 75.7. Same for the voltage across the inductor, 48.4. It was noted that it appears that these two voltages don't comply with Kirchhoff's voltage law, but that's because they're out of phase with each other. If you draw the phasor diagram, they are the resultant of the two vector components. And so if we convert them both to rectangular form here and add them together, we should get a result around the supply voltage, only allowing for errors in conversion or rounders in conversion. Alright, so that's the first part of AC analysis. Next week we'll go on to consider what happens when we bring all three components together and calculating using a parallel element, and also think about some simple work with Thevenin's in an AC circuit, because you can use those theorems with AC circuits just the same. It's just that your maths is going to be complex as opposed to just normal numbers. Alright? So